Hello, good morning, good afternoon, good evening, wherever you find yourself in the world. My name is Kevin Breen. I'm the Director of Cyber Threat Research here at Immersive Labs. And today we're going to be taking a look at Nobelium. More specifically, we're going to take a quick dive into some of the malware that they've used, and we're going to do a little bit of reverse engineering. We're going to talk a little bit about incident response and some of those fast things you can do to get that. So this webinar is being recorded and will be available on our YouTube channel and in other places once we're done. So we'll make sure to get the link out to you. And yeah, so if you have any questions at all as we go through this, then please stick them into the question channel. I will try to pick them up as we go through. If I can't answer them all now, we will try and get back to you when we go through. But again, don't be shy, get in there and ask the questions as we're going through this. We're short on time. This is only half an hour and there's a lot of content to cover, so I'm going to go relatively quickly. So again, if there's anything you want me to do to slow down, then by all means, just ask me to slow down and I shall try my hardest. So with that, I'm just going to attempt to switch over to the correct tab. Okay, so just a little bit of background on Immersive Labs, and these are all available for you to play along. So if you head over to community.immersivelabs.online, there'll be a coupon code there. You can register an account for free, sign in, and all these labs will be available. So you can play along with us live as we go through these now, or at your own leisure. Afterwards, they'll be available for at least a couple of weeks after we finish this. So please go ahead and play through there as we go. So Immersive Labs is an on-demand platform where we can deliver practical cyber training and development of those cyber skills. And the whole concept is all around actually getting people engaged in those practical skills. So what we have is a web platform. You can access it through the browser. And what we'll do is on demand, we'll spin up a private instance just for you, and then we'll get you into it. And that's what we're going to play with today. So specifically here, we're talking about Nobelium. So Nobelium were probably most well known as APT29, or for the related to the Sunburst attacks that we saw in the tail end of 2020. So Microsoft have put a lot of documentation about the original Sunburst attacks, and obviously that picked up a lot of traction in the US. And this is very loosely affiliated by these people as being Russian state-sponsored attacks. We're not going to focus on any of that attribution today. What we're going to look at is taking a look at the attack methodologies, some of that malware, focusing on the techniques these attackers used to really stay under the radar. So what we've done is we've broken this out over a set of 5 labs. The first lab, we talk about like who are APT29, who are Nobelium, like what are the motivations, look at MITRE mappings and things like that. So I'm going to skip over that one. And then I'm going to jump into what is effectively our first lab. So this lab is MV Scout. So we know that when Nobelium deployed this, this started off as a set of phishing campaigns, a set of phishing emails, and those emails came with a HTML attachment. And one of the really interesting things we saw Nobelium do was they kind of iterated over this process. So there are several variants of this, and some of them just did some tracking. Some of them detected who clicked on links. Some of them delivered full payloads. And that's one of the things we're going to look at today. So what I've got here is I've got my analyst desktop. It's completely isolated away from the internet, so I don't have to worry about actually connecting out to NEC2 or any attacker's infrastructure. I can just go ahead and play with this. So this lab and all the other labs with it will give some really rich detail around these techniques, around some of the stuff we're going to be looking at. They'll go into some more of the details on how this works. There's a set of tasks that you can go through, complete these, answer the questions, pull out the relevant information, and as you complete these, you'll score points and leaderboard. We're not going to go through all of those questions today, although we will be touching topics on them. We're going to be looking just more specifically at the malware. Like I said, we're going to look at some dynamic analysis, some static analysis. but we're not going to go really deep into this. We're not going like full-on debugger, although we are going to step into Gidra and some debugging. But what we're looking at is like, what is some very quick information that we as defenders can pull from these malware samples in the shortest amount of time, so we can get this over to our network teams or to other SOC teams or CERT teams, so we can start to do more threat hunting. So this whole analysis that we're going to look at is focused on like quick, dirty techniques to get the information we need in the shortest amount of possible, for more when we're dealing with these events in real time. You'd come back afterwards when you've got more breathing room to go and do a really deeper dive into it. So like I said, isolation from the network, so I'm happy just to double click on things and see what happens. It's a quick way of getting stuff, and straight away we can see that this looks fairly standard in phishing, but there's not a lot happening right now. I can see that the browser's trying to load stuff, but there's not a lot happening. So I'm just going to stop that, minimize that, and then take a look at the code. So just open this in a text editor, like any text editor of your choice is going to do the same thing. And then we're just going to go through this and pull out what's happening. So we don't see a lot happening from the front end, but I'm assuming that something's happening as we go through this. So this loads, and the first thing I notice, like, it's taking a while to load, which indicates that it's something more than just a HTML file. And we can see the size of this thing's almost a couple of meg. So start off looks fairly standard. I can see that's a big 64 encoded picture. That's fairly standard for this kind of stuff. I can see that same text that I was seeing when I opened it up. And as we continue to scroll down, we can see some JavaScript. JavaScript alone doesn't necessarily mean anything malicious. So this looks like it's not obfuscated. It looks like it's been packed or minimized, more about making it hard to read than anything else. And we can scan through this, and there's a couple of interesting things we can pull out. So it's looking at the behavior, it's looking at user agent strings. It looks like it's attempting to fingerprint the browser we're opening this with. If we continue looking down, we can see that it's constructing, or it's checking for elements, and then we can see it looks to be creating something to do with a download function. So I can see, depending on whether you're coming in Microsoft or whether you're coming in some other OS, or if you're coming in Firefox, then it looks to be creating some kind of download link. And then as I go through, I can see that it looks like it's creating data elements down here. So a little bit of information, nothing that really gives it away. And I can see it's exporting a save as function from here. So that's interesting, but nothing immediately jumping out as being strictly malicious. That looks odd. So line 79 there, I'd expect to see code. I'm seeing what is effectively gibberish in this view. I might have a different look in a better view, but that looks a little bit weird to me. It's not what I expect to see in a normal HTML file. Coming down, I can see some more JavaScript. Now this one looks a little different. So whilst the first one looked to be minimized, this one looks like there is some obfuscation to it. So like function names aren't exactly friendly named. But again, there's some stuff we can infer very easily. So it's taking the path name of the file we're opening, it's removing slashes, and it's checking to see if it starts with a C colon. So straight away I can see this thing is targeting Windows. And anything Linux, Mac, or mobile based isn't going to respond. That's not going to evaluate to true. I can see it's reading from a variable here, which is probably going to be what we've got here on line 79. And this one here, big giveaway, that's XOR. So it looks like there's some XOR encoded data there, a really standard way of obfuscating things away from static signature analysis. And then it looks like it's going to convert it from base 64, which is A to B, do some other stuff with it, and then octet stream, and then it's going to trigger that save as function, which is that function all that code we saw above. and it looks like it's going to trigger a save as mv.img file. So we can see that that didn't trigger when we loaded it, and that makes sense why, because we're not on a Windows device, we're in Linux, so that download didn't trigger. So I could take that block of text there, I could deobfuscate it, I could decrypt it, but there's a dirtier, quicker way that I'll show you in a second. Continuing down here, we can see a couple of another block. Again, like these things look like they've all been tacked together from different sites. So you'll notice the structure and stylistic behavior of the JavaScript is different. So probably bits of borrowed code that have gone here. Again, all of these things help avoid attribution. So here we can see we're constructing a HTTP request. We're going out to API ipiffy.org. If you're not familiar with this, this is a public service, so not strictly speaking malicious in its own right, and it's just a way of getting your external IP address from the inside of a network. So on a normal network, I'm going to get a local IP address, so like a 192.168 or a 172 or a 10 dot range. Most attackers care about your external facing, so this is just an easy way of them to be able to get that. So like I said, not strictly speaking malicious in itself, but we see it used a lot with malicious intent. So it makes a GET request there, reads the response, and then allocates that to a string called SDF-GHF. Interesting. It reads the user agent, so it gets the user agent, and again allocates that to a variable. And then it gets the path name. So we saw it do this check before to check whether it was in the C drive. Now it gets that full path, and then again allocates that to a variable. Now this is somewhat interesting. So here what we've got is we've got this this HTML page getting my external IP address, checking that I'm on Windows, and then getting the path it's running from. And one of the most interesting things about the path is if this is opened in a standard user account, that path will contain the user's name. So it's going to be C users username / desktop or Outlook or wherever the file ended up being loaded from. So there's actually a reasonable amount of information that gets given away by that path name. Gets thrown into an object, converted to JSON, and then we see it sent off to this URL here. So a couple of really interesting things here. Eventbrite.com. This may or may not be Eventbrite.com, but it shows, if we remember what that original thing looked like, it was we're being invited to something. That's what the whole HTML page was showing us. It's saying you've been invited to this occasion. So actually, Eventbrite kind of makes a little bit of sense in that context. This is a way of them continuing to make it less obvious to us as we're doing the analysis on whether this is bad or not. And Firebase.io, this is a web application actually delivered by Google, which is designed for web applications to be able to store and process data. So unlike some more traditional attacks where the attackers run their own C2, what we're seeing here is we're seeing a lot of legitimate services used as part of this chain. And then it makes that post request off sending our data out. And like I said right at the beginning, we saw a couple of different elements. We saw them sending just this enumeration block. We saw them sending MV image. We saw them sending other things. What I'm interested in next, I want to know what this MV image file is. So just because this isn't going to load, I'm just going to stop that from rendering. We also know that this isn't going to trigger if it thinks that I'm not on Windows. So when we open this, this is going to load from Home Forensics. So if I change this check here, I can just say, actually the first letter is going to be AH, and the second letter is going to be an O. So if I save that, close that, let's just close that one, close all the tabs, open this up again. And now we see I'm prompted with that pop-up box. So this is how it would appear to users if they were on a Windows device. And I'm just going to hit save on that. And again, on a Windows, because Windows recognizes the IMG type, it would actually prompt you to either save, open that. So What I should be able to do now is just go into my downloads folder. In there, I can see that MV image file. And if I unzip that, 7C, and have a look at what it's dropped, I can see it's dropped a boom.exe, an LNK file, a PDF file, and another folder called MV. So very quickly, in a relatively small amount of time, what I've done there is I've managed to figure out how it's fingerprinting devices, what kind of information it's going, where it's sending it to, and then what it's dropping and deploying onto users' box. These are all things that I can now go, all right, if I've got EDR, let's check for the presence of these files. We kind of know where they're going to exist. If I've got network analysis, if I've got IDS or IPS in place, I can start having a look there. Or even if I've just got DNS logging, I've now got DNS names I know somewhat affiliated with this, so I can go and check and see if any hosts have made call out to those DNS. And again, just very quickly building up on that information. So that's the end of that one. So now we've got this boom.exe file, so we're going to go have a look at that one. So I'm just going to kill this lab, jump over to our next lab. So in here, so we've got a boom.exe file. We want to see what this file is doing, like what are its capabilities, what's it doing when it runs on the box. So I can take a look at my malware. And again, so this box fully contained, no access to the internet, so I don't have to worry about just double clicking, running stuff. It's not going to go anywhere. So this is that MV image file. And like I said, if we open that, this is how it would appear to the user. So there's a hidden folder called MV, a hidden boom.exe, and we've got this shortcut file. And if we have a look at the properties on this, we can see this shortcut is actually going to call cmd.exe and it's going to start boom.exe. So it might look like it's a shortcut to a folder, but actually it's starting that exe file. So let's take a look at this exe file. And I can see this is a 32-bit .NET assembly. That's the really interesting part here. That's the thing that's going to give us the most. For those of you familiar or not familiar, one of the hardest things with malware analysis is that most things don't come back to the source code. Like you're looking at assembly, so you're going to have to go into like some really complex routes. You'll have to go into debuggers. Whereas with .NET, we can actually get a fairly good approximation of that source code through a couple of tools. So there are commercial tools, there are free and open source tools. What I'm using here is DNSpy, which is hopefully going to open in a moment. So DNSpy is open. I'm just going to chop my executable file into here. Okay, no, I'm not. Let's extract you here. Close that. Sorry, talking and doing is not my strong suit. Okay, so there we go. So we've got boom.exe, and like we can see a very close approximation to the source code. We're not going to get all of the comments and things like that, but this is fairly close. We've got the compile time. Now, again, this can be spoofed, but it's a good indication so we can see when this program was created, and it tells us the entry point. So that's the first thing this malware is going to call. So when we jump into this, it's fairly easy for us to follow through what's happening. So I can see that the first thing it does is checks the presence of that MV directory. And if it's there, it opens it in Explorer, mimicking the behavior of that shortcut icon that we saw. So if you double click on it, the binary launches in the background, a folder pops open, which is what you'd expect it to do, so it feels less suspicious. And inside there is a PDF file, which is completely legitimate. It doesn't do anything. Then we can see it's checking for the presence of some DLL files. It's creating a couple of byte arrays to save you trying to decode this by hand. You can drop this into something like CyberChef, and this is actually a PDF header and a PDF footer. It then generates an MD5 of my host name, a and then it calls this function, new host, get host info. And we can see this one's getting my host name, my domain name, if I'm on a domain attached device. It's getting my IP address, and it's getting my username. And then it's constructing a very specific string. So hn colon host name, d colon domain name, followed by pipe separated IP addresses, and then my username. So a lot of information is being packed together there. Then we see it's being encrypted using AES. So if we jump into here, this is the AES crypto routine, and we can see it's fairly standard as far as crypto goes. But we can see it's also passing in the IV and the key. Those are hard coded in the binary, which means we have the key and the IV. So what we have is the ability to recover this. Oh, can anybody hear me? Sorry, I'm not sure if anything's happening, and I've got somebody saying they can't hear me. Cool, thank you. So a moment of panic there. Can you see my screen as well? I see people are responding to me. Amazing. Sorry about that. A small moment of panic when somebody says they can't see my screen. Okay, going to carry on then. So again, we've got this key and this IV, which is static, hard coded in here, which is really useful for us. And then we can see that it combines the PDF header, those encrypted bytes, and then that PDF footer, and sticks our encrypted bit in the middle. And then we see it calling upload file, and it's going to push to old/0arg, which is the MD5, so that unique thing that it created for us. So if we take a look at this upload file function, we can see it's creating a web request, which is fairly standard. If we look at the content domain, we can see this is actually pushing up to Dropbox. And we can see that whoever put this malware together has made no attempt to kind of try and obfuscate what they're seeing here. So we can see, again, they're using legitimate tools, legitimate services. So they're creating an encrypted PDF file, uploading it to Dropbox. Now, we know exactly what this looks like now. So we know it's a fake header, a fake footer with the encrypted data in the middle. So if we're doing things like SSL inspection, or if we can capture this traffic, now we can actually go and see if something was uploaded to Dropbox and we can catch it, we can now decrypt it because we've recovered those keys from here. In this specific instance, if we continue down this flow, we'll see once it's uploaded that information about us, one of the next things it does is it will attempt to download a file. So it's actually going to download files using the same methodology. So if we have a look at the add rule function, we can see here it checks the existence of these folders, native cache, system certs. It downloads from Dropbox this manual PDF and this README PDF. And it's exactly the same way as we saw before, so using the exact same encryption. So again, if we've managed to intercept that, if we can't get this on box, then if we can recover this from traffic, then we can decrypt those files and we can move on. Just very conscious of time, just because I want to give you as much as I can. And again, these are all available in community mode, so you can go there afterwards and run through these in more detail. But if I jump out of this lab, go back to Nobelium. So those two files that we saw downloaded from Dropbox, these are what Microsoft have called Native Zone and Vapor Rage. So these are two DLL files. And unlike the last boom.exe we saw, these aren't in .NET, which means it's not quite so simple to be able to pull information out of it. But I'm going to show you again how with just a little bit of knowledge, we can pull some really rich information out early on that can further these investigations quickly. Ghidra, if you're not familiar, is a free tool released by the NSA, and it's a very powerful analysis tool for not just Windows binary files, but a whole host of binary files. And what this is really good at is it's going to give us a very close approximation to what that original source code looks like. So here we've already created the project for you, so we can jump in, open this up, and we can see native cache and cert PKI, those two files that were downloaded and executed by boom.exe. So we know that boom.exe used run.dll, and we didn't see this, but boom.exe uses run.dll to call native cache service. And it's not like a binary file, so when you double click it, it doesn't just run. You need to call an export or an entry point. And we know the export was this config native cache. So on this left-hand panel, so this is the assembly, and anybody who can read this, hats off to you. Like, it took me years to learn assembly and like deep malware analysis. But what we're focusing on here is how can we as incident responders get some quick information like very early on. So if we ignore that window and just focus on Gidra's ability to decompile that back into C, and appreciate that for some people this may still look like a lot of gibberish. But there's some really important things that we can pull out here just from looking at the strings. So we can see it's calling an API to get hold of a folder path, and if we look at that API on Windows, we can figure out what it's doing. We can see it's using sprintf to construct a string, which takes that folder path and our DLL file. We can see another function calling run.dll32. It's passing two strings in, one of which is that file path we saw, and the second one which is get configs, and then it's using the Windows API create process to actually start that. So this doesn't have a lot of functionality in itself, it's just another loader. And what that means is the attackers can set this one to maintain persistence with a run key, which is what happens, and then they can change the DLL file at will, which is what contains the actual implant. So again, really quick information we get from here. So we know that we've got this other DLL file, and we know that it's going to be calling this entry point. So again, if I open this one, jump in here, and again, this one gets more complex quite quickly, but we're looking at what are the important quick things we can get from this. So we know exactly which export we're calling for, so we can jump straight there. We can see it's doing check to see if this file exists. We can see it's constructing some strings. This seems to be using a username, and if we have a look at this function, domain name. So again, just more data about us that's being sent to the attackers, most likely. This looks like it's doing some kind of basic loop obfuscation. So it's probably doing some basic encoding of that. And then we can see another function is called with that, and then it's going to sleep and then continue to loop. So it's going to run this, sleep, run this, sleep. So jumping into this function, this starts to look a bit more familiar to us. So we can see it's constructing a URL to what looks like a WordPress site. It's taking that parameter in, which is that encoded username and password, username and domain name that we saw. It's got a session key and a type. I'm not sure what those are used for. At this point, we can see a user agent string. We can see the domain that it's attempting to contact with Internet Connect. And this number here is actually the port number. So 0x1 Bravo Bravo is hex equivalent to port 433. So we know this is going to make a HTTPS connection to this domain, this user agent, and this string looks immediately signaturable. So now we've got a lot of information. Again, we can go to network logs. We can start to look for DNS queries. We can look for any devices that are contacting out. So within 30 minutes here, minus a couple for me checking people could hear me, we've actually managed to pull a lot of really rich information that we can use to understand what is the impact this attack is having on us right now. If you dig more into this, you'll see that it opens a request, pulls it down, and then what it actually does is it downloads shellcode, decodes that shellcode, and then executes that shellcode, returning the response to the attackers. So you can go and follow all of those things through, but what we're focusing here on is just those really quick instant response elements. The final labs in this series take a deeper dive into some of those network traffic. So we replicated this attack. We caught it all as it was happening with SSL and TLS intercept. So you can see the difference between grabbing these things where you've got limited viewpoints of just looking at DNS and connect strings in your traffic versus the power you get from being able to proxy these things and being able to pull that really rich data out. And that brings us up to the half-hour point. Like I said, that was me talking very, very quickly. All of these labs are available on community.immersivelabs.online. Please do go make good use of those. They are free. You just need to sign up and use them. Yeah. So I suppose any questions, if you want to ping them in. I know we're just over the half-hour mark. I've got some time if people want to hang around and ask me some questions. If not, thank you very much. If you'd like more information about Immersive Labs, please head over to immersivelabs.com. These free labs, community.immersivelabs.online. If you liked listening to me talk really quickly, I join 3 of my fellow colleagues in a technical podcast that we run once a week, and you can find that by looking at Cyber Humanity, where all good podcasts are found. And that is it from me. Thank you very much for joining me on this very fast instant response malware analysis journey.